Today's video is going to be on how to use your calculator. So if you do not have your calculator out yet, please press pause and get it out. First, we're going to look at a couple different functions on your calculator just so that you know where they are. The first one is absolute value. And we've talked about absolute value a little bit. We're going to talk about it a little bit more later with graphing. So anytime you need to find the absolute value, the bars aren't in the calculator, but what you want to do is hit the math button, arrow to the right so that the number is highlighted, and the very first thing that you see there is ABS, that's absolute value. So if we want the absolute value of a negative 9, you'll see that it'll evaluate for you at a positive 9. So anytime you need to know what the absolute value button is, you hit math, arrow on over under number, it's the first thing there. Alright, the second one is the square root. So if you look down the left-hand side of your calculator, you'll see the square root above the x squared button. And you notice that on my calculator, it's in blue. So you want to hit second x squared. And let's do the square root of 9. We get the square root of 9 is 3. Exponents. If you want to do an exponent, we know if we want 8 squared, we can go ahead and hit the shortcut button. And we can get 64. If we want to cube something, let's say 8 cubed, we can hit math, and you can see that we've got the 3, a little 3 right there, number 3, and we get 512. You also can do anything above 3 you don't have a shortcut button for, so let's say we wanted 2 and we wanted to raise that to the 6th power. You need to use the caret button, which is right underneath the clear button, so 2 to the 6th power, and we get 64. Now if we wanted negative 2 to the 6th power, notice how that gives you a negative answer. If you wanted to raise the entire negative 2, make sure that it's in parentheses, to the 6th power. You can also do squares and cubes this way as well. So if I wanted 8 squared, I could do 8 caret 2, and I still get that 64. If we go back to math, underneath math, we've got a bunch of different things. The cubed, you can take the cube root, you can take any other root. But one of the most important things is changing something to a fraction. So let's say you wanted to, we've got 15 divided by 200. And when you divide this, your calculator gives you 0.075. No, this is not 3/4. 3/4 is 0.75. So we want to find out what that is as a fraction because all of your answers should be given to me as a fraction. We hit math. The very first thing there is arrow to a fraction. That's changing a decimal into a fraction. We hit enter. So we take that last answer, make it into a fraction. Boom, our fraction is 3/4. So it's really important. It's called math frac, math 1, enter, enter. If you ever want to change a fraction into a decimal, you can just divide it, or number 2 will change a fraction to a decimal. Alright, so those are some basic things. Now let's get into graphing. If I want to graph y equals a negative 4x plus 20 in our calculator, we go to our y equals button in the top left. If you have other equations in there, go ahead and just clear everything else out. Sometimes there's a bunch of equations that get stored way down below, so make sure that you don't have anything else in there. And you want to make sure that all the stat plots at the top are turned off. So you don't want plot 1, plot 2, or plot 3 to be highlighted. Let's say yours is highlighted, so if you have plot 1 turned on like this, to turn it off, you highlight it, press enter, and that will turn it off. So we're going to enter in our equation of a negative 4x plus 20. And notice that I use the negative button right here and not the subtraction button. They are two different things. Alright, so if we look at our equation, we entered it in. What is our slope? You know that your slope is going to be a negative 4, and your y-intercept is going to be 0, 20. We're going to hit the graph button. And when you hit graph, can you see the x-intercept? Well, yes. Our x-intercept is located right here. Can you see the y-intercept? No. If we look at our graph, we know that our line is leaning this way, so it's going to hit our y-axis way up here. What you want to do is change your window so that you can see the entire line, including the y-intercept. And to do this, we're going to change our window. we've got x min, x max, y min, y max. You're never going to change the x scale, the y scale, the resolution, anything like that. So what we're going to do is change the x min. Oh, let's look back at our graph. We need to figure out, how do I need to move the graph? Do I need to move it left? No. Do I need to move it right? No. Do I have to move it down? No. What I have to do is I have to move it up. The x min will move your graph left, the x max will move it right, the y min will be down, the y max is up. So what I want to do is I want to change it up. And I know that my y-intercept, we've already decided, is 20, so I want to go above the y-intercept. So I'm going to go to 25, and we hit graph again. And now we can see the whole thing. So in this case, we had our x min stay at negative 10, our x max at a positive 10. We have our y min still at the negative 10, and we changed our y max to 25. We sketched that graph. And the next thing is trying to find different values. So we have the equation. I want to find y when x is negative 2. Now yes, I could just plug negative 2 into the equation. I also can do it on the calculator. And I want to make a calculation. So you can see it written up in blue right above trace. So I do second trace. And the very first thing there is value. So I hit number 1. And it'll say, what x value do you want to find? Well, I want to find negative 2. And it will give me the corresponding y value. So when x is negative 2, y is 28. That means that on my graph, I have this point of negative 2, 28. Okay, moving on. For number 4, we've got 2 times x minus 6 is equal to 7x plus 15. Our last equation, we had y equals. In this case, we have two pieces, no y equals. The left-hand side is going to go into y1, and the right-hand side is going to go into y2. And you actually don't have to change anything about it. You don't have to distribute the 2. You don't have to make any you don't have to simplify anything. So we've got 2 parentheses x minus 6. And we go down to y2, 7x plus 15. Alright, instead of pressing graph, what we want to do is we always want to start off in a standard window. For our last problem, we had to adjust it, so we had changed our y max. So we're going to go to zoom, 6, and that's going to change everything back into your standard 10 by 10 window. Now we can't see our whole graph here. We don't have to move it left, right. We don't have to move it up, but I can see that my lines are kind of verging down at the bottom, so I want to move it down. If I want to move it down, I'm going to change my y min, because remember, x min moves it left, x max is right, y min is down, y max is up. So I'm just going to double that to negative 20, kind of guess and check here. And I still am not quite there yet, so I'm going to go back to window. I'm going to change that negative 20 to a negative 30. Hit graph. And now I've got it. So our window, we didn't change our x's, so our x min is still at negative 10. Our x max is still at a positive 10. We changed our y min, ended up being at negative 30, and we did not change our y max. So that's still a positive 10. So if we look at the problem, we want to find out when the left side equals the right side. So hit second trace. If I want to find out when those two things equal each other, the only logical choice, the only option that's going to make sense is I'm looking for when they're going to intersect each other. So I'm looking for the intersection. Anytime you want to find out when two things equal each other, you're looking for the intersection. So it's going to ask for the first curve. If you look in the top left-hand corner, it's always going to start in y1. So I hit enter, that's the first line. And then it's going to automatically bounce to y2. Hit enter again. And it's going to ask you to guess. So you can see right now it's at 0, 15. If I arrow to the left, I can see the cursor. And I can be this far away and hit enter. and it will give me that my intersection point is a negative 5.4, comma, a negative 22.8. Now that's not your answer, your solution. If I look at the problem, the only thing that I see is x. So that's what I'm trying to solve for. I'm trying to find the variable that the question has. So my solution is a negative 5.4. Okay, moving on. When you are dealing with two lines, so like we just were with y1 and y2, if you happen to have parallel lines, that's when you have the same slope and different y-intercepts. If you have parallel lines, then you're not going to have any intersection points. And if you don't have any intersection points, then you can't have a solution. Now, if you happen to have the same lines, which means you have the same slope and the same y-intercept, that means that you have the same equation. That means that you're going to have infinite intersection points because you're going to have two lines right on top of each other. That means that they're always going to be intersecting each other. And that means that you're going to have an all real numbers solution. If you have vertical lines, which is x equals some number, you can't put those into your calculator, so what you want to do is do them by hand. Yes, I know some calculators will do it for you, but not all will. So vertical lines, if it's x equals, then you need to do it by hand. Your calculator, if you go to y equals, all of your equations are set up so that it's equal to y. So if it's equal to x, you can't plug it in. Alright, so let's talk about if we get an error message. If you get an error message, like we talked before, check to see if those plots are on. If they are, turn them off. Check your window. A lot of times some people will go 10-10 and they'll hit graph, and then it'll say window range error. Anytime you see window range error, you go back to your window, and this is the min. That means that the min has to be smaller than the max has to be smaller than the min. The same is true for your y equals. Look at your options on your calculator. Every time you get, most of the time, not every time, most of the time when you get an error message, it'll say quit or go to. You always want to choose the go to. It will bring you to where you made your mistake. Lots of problems, we don't always use x, so if you're given an equation of y equals 3b plus 5, even though it says b, every single variable is going to go into your calculator's x. And remember, this is where you're going to use this button for x. You're not going to use alpha x. You're going to use the x button. Now, time for the line of best fit. This one takes about the most amount of time. What you want to do is start off by hitting Stat, and you're going to edit your data. We want to enter all of this stuff in. When you edit your data, your x's are going to go into list 1. Your y's are going to go into list 2. So right now what I want you to do is press pause, enter all of your x's into L1, all of your y's into L2. Alright, now that you've entered all of your data in, we're going to go back to the home screen, so second mode, and we're going to hit Stat, arrow to the right, and we want number 4, lin reg. We are trying to find the linear regression line between those data points, so we want L1, so second 1, comma, L2, and that's telling you your x comma your y, and then it will tell you in your calculator that you have y equals ax plus b, and it tells you that your a value is 1.98 and that your b value is a negative 0.5 round, so that your line of best fit is y equals 1.98x minus 0.57. Even though it doesn't use the m and the b, it uses a, b, it tells you what a and b are. And there's your line of best fit. That's going to be your linear regression line. This isn't an exact linear relation. It's the best line that's going to fit all of the points. And we're going to use our linear regression over and over and over again. Alright, and that's it for today.